All right, so some additional substitution techniques. So in order to use the substitution method, the integrand must be expressed entirely in terms of u and du. We know that already. And in some cases, the integrand must be modified before making a substitution and using one of the integration formulas. Well, what this means, so this means we might have to multiply or divide, depending on the problem, by some uh, constant number to make the equation still equal. Because when you do one thing, when you take and start substituting u and du, it might not actually get the same thing. So if we remember very at the beginning, we had that one where we had a 3 and then it was e to some power. And then the next one we said, well, we're going to have only e to some power. Well, we didn't have that factor of 3, so we had to multiply by 3 here. And then we put 1/3 out in front here. So that's what we're talking about. We're going to start doing that now. So looking at this one, what do we have? Well, here, let's do A. So it looks like if I want to do this, I'm going to use that as my u. So I'm going to let u equal a minus 3x. Well, that means du is going to be a minus 3 dx, right? But do I have a minus 3 in here? No, I don't have a minus 3. So that means I'm going to have to multiply by a negative 1/3. And so if I multiply that by a negative 1/3, I'm going to have to multiply this by a negative 1/3. And so then when I set up my actual indefinite integral with the u's and du's, what I'm going to have is a negative 1/3 out in front. And then I'm going to have e to the u du. Because now I've got that negative 3 I multiplied by, but I also divided it by. And so now that's my actual thing. And so now, do I know how to do that? Well, yeah, that's negative 1/3 e to the u plus c. Now, my u, I'm going to substitute back into here. So that's a negative 1/3 e to the negative 3x plus c. And so that would be then my final answer. So again, we had to multiply this one by the negative 1/3 because we didn't have a negative 3 here. So if we multiplied it, we'd have to do that to make it work. All right, what about this one? For this one on B, let's let u equal x squared minus 9. Okay, well, du is equal to what? Well, that's going to be equal to 2x dx, but that's a 2x here. I've only got a 1x here. So I've multiplied by 2 to get that. So that means I'm going to have to multiply everything. We'll put that and put the half here. So I'm going to just multiply this side by half to get this side to be equal to what's up here. So now if I do my integration, I'm going to have my half out in front, and then I'm going to have what? Well, I'm going to have that u and or that x dx is going to give me a du. So really, I'm going to have 1 over u du. That's what happens after you substitute everything in. Well, 1 over u is what? Well, that's going to be 1/2 ln absolute value of u plus c. Now I've got my u here, so I substitute it back here. And so I have ln of x squared minus 9 plus c. And that gives me my final answer for the integration here. All right, what about this one? Okay, well, again, I'm going to look at the inside thing. Something that usually is to a power is going to be the inside piece, and everything else is going to be the outside piece that you've taken a derivative of already. So let's keep sticking with that. So let's let u equal t to the third plus 4, and so du must be what? 3t squared. Okay. Well, that's 3t squared. I'm supposed to have a 5t squared. Oh, yeah, and then a dt. And I've got a 5t squared dt instead of a 3 squared dt. So what do I need to multiply by? Well, I need to multiply by a 5 over 3 because if I do that, that gives me a 5. So if I multiply this side by 5 over 3, that should give me what I need. So again, I want this side over here to look like whatever is left. So that would then give me, well, I'm going to have my 5/3 out in front. Now remember, this is what this is. So that's going to be a what? U to the -2. And then I'll have du. All right, so that 5/3 stays there. I'm going to make that u now to the -1 over a -1 plus c. Well, that -1 just makes that a -5/3 out in front. And then I'll have what? I'll have a t to the third plus 4 all to -1 plus my c. And that then gives me the integration by substitution of this initial problem. Okay. All right, so let's stop there and we'll come back for some more.